see our first presenter here.
I'm prepared because I went back and reread the whole email thread.
Okay.
Oh.
Just start.
Oh, I read it on the plane. It did not. I got one question for the beginning of it.
Yeah.
It seems to me you wouldn't really need to do it unless you were doing some kind of flooding reduction.
Well, it's
Anyway.
He's gonna get hungry if we talk.
Yeah.
Okay, let's get
Let's
started.
start, yeah.
Is it time?
Yeah.
Oh, it's time.
Which we know that it doesn't pick up our voices unless we're doing that. There's one right there. Stand up.
I want to be able to hold it.
You wanna walk like
Yeah.
Taylor Swift.
You don't want to see my imitation of John. No. Hello, everyone, to the LSR meeting. Hopefully, all of you will sign in. We got a nice intimate venue here. Anyway, I'm going to go right. Okay, there was a long discussion on this, but I was on the working group share, so you didn't see it. You know, there's maybe making this similar, but the two main points are IPR. If you know about IPR, on any of the presentations or documents, you're obliged to disclose it. The other main point is be nice to people and do not limit your arguments to technical arguments and no, what is it? What's the Latin word? Ad hominem? Yeah, attacks. So hopefully, we've had some real controversy in this working group, but we've done, I'd say, a fairly good job of keeping the arguments technical. So anyway, we're not supposed to say we've done a good job?
No, we're not.
Okay.
It actually dissuades people that might have had trouble.
Oh, sorry. I didn't say that.
Scratch that.
Yeah. Yeah, sign in. Those who are just entering the room now, remember to sign in with the in-meeting tool and on-site tool in MeetEcho. Okay, join. If you can add to the minutes, that's good. We made as the recordings and transcription and everything are available, we made the minutes to become more and more just key points regarding the discussions, and they become sort of short. And then what we do is we take also participate in the chat in the MeetEcho, we've included the MeetEcho chat for posterity. Okay, working group status. We've finally gotten some of these across the line. Prefix tags actually went pretty fast, probably because we'd already done it in ISIS in the most, the biggest, we got the most comments, not surprisingly, on the Yang extensions. IGP flexible algorithms, there's a number of implementations of at least parts of this, at least the bandwidth metrics and some of the others. So it was good we could get this base document. We like to get the Yang model, and Yingzhen's going to talk about that done in the next couple IETFs. And finally, this was the multi-part. What started out is just what was seemingly going to be a effort just to document the current behavior of a number of the predominant implementations, turned into a discussion of what ISIS should do long-term, even though, and we talked about compatibility and things like that. So that took a long time, but it's good. We finally got it as an RFC. We got these two on the queue. I pinged the RFC editors as to why it's these two. These are the two final, these MPLS SR documents are the final documents that were started prior to the merger of the ISIS and OSPF working groups. So those are the only ones left. After these two are published, you'll be able to just search for -LSR- and see all the LSR documents. And then we got those two new ones are also on the RFC queue. So hopefully we'll get reverse affinity. That's a real simple one. That went really fast. Just a flexible algorithm for the reverse direction for applications, and there are some use cases for that. And then the unreachable prefix, that's an experimental one. That one, there's a lot of controversy on that one as to what problem it should solve. And I think we got a nice limiting of the problem to the notification of the unreachable prefix, other entities in the control plane, and reached rough consensus on that one. We just got this submitted. This is a pretty simple one. We already have this flag in ISIS to say whether a prefix is an anycast or not. There's a number. We took out the use cases, but there are some use cases, like for instance, if you're looking at backup paths, you really don't want to include in the backup paths using something like segment routing. You don't want to include a node that has an anycast or any SID associated with a node anycast address, because it could be interpreted differently to somebody who's in a different place in the network. We adopted an experimental draft that goes back to a couple years ago. It kind of quieted down. This is a pretty straightforward algorithm for computing a flooding graph of an area, and some it goes with the infrastructure for dynamic flooding that we already have as RFC. I forget what it is, 93 something. And then we have the soft data plane which is an encoding to allow flexible combinations of flex algorithm, metric, and other SID and everything else for flex algorithm. Okay. Yeah, we closed on these. We closed the working group last call. I'd still like to get some reviews. We got a good Yang doctor review. I'm going to try and get the two ADs who normally review Yang models, Med and Mahesh, to review these as well, because they generally have some good comments before we actually send it through you to the IESG, Gunther. And we think that one above is ready. Just making OSPF consistent with ISIS, where a link with an unreachable metric is treated as unreachable. Now, you know, the OSPF encodings, which date back to the early 90s, the base topology and IPv4 unicast address family are fixed format, always there. But there are cases where you want to advertise other topologies, other flex algorithms, all sorts of things. So, but you don't want to use it for that. So this allows you to exclude those links. Before, they were just less preferred because the link infinity wasn't taken as unreachable. And the hard part of that one was the backward compatibility, of course. And then we got this one. We're just waiting. One of these is already in working class call, and apparently Spring's going to do that pretty soon. The SR enhanced VPN is going to be last called. Okay. And then we have these Yang documents. I'm not going to say anything about these because we got a presentation. We had some extra time on the agenda, so we're going to have a presentation just to see where we are with Yang. What we're trying to do, and Chris initiated this, and we've done it in a lot of them. And Ying Zhen's actually helped out some other smaller documents by providing some for the authors. We're trying to get the actual augmentations, including in the draft that includes the IGP feature, so that it all comes together. And this is definitely, I wish Rob Wilton used to ask for this every draft that we sent him when he was AD. So we'll have to tell him once we get there. And I'm not going to say anything about this. This algorithm, except we probably will try and do this one. Apparently, we're going to re-socialize that at the next IETF. The authors are going to represent it. We were almost ready to working group last call it, but we decided to do flex algorithm bandwidth constraints and metrics, because there were actually parts of that draft were implemented by both Cisco and Juniper. So we did that one first since it was. I don't think any of these others, these are just ones that are working group documents. I think maybe the last one, we should have some discussion on that simplified flooding framework. We should really, I think we should do that and do it at the same level as I mean by level, I mean document status level, as we did the initial flooding framework. And that's it. I took a little longer this time just because normally we're so rushed. We're using every minute of the time, and today we weren't, so you got to hear me talk.
We have someone in the queue.
Okay. Jacob Cormier. Oh, it's error. Okay.
So the room is getting packed. Can everyone make sure they please sign in to the on-site tool so that we have a good record of how many people came, so we're not stuck in a tiny room again?
Yes. Oh, yeah. Right. Do you want to?
Good to see you
Colby?
walking. I haven't seen you since the accident.
Yeah, it's been
Long
about
time.
4 years.
Ah,
I think so.
Try it. Point to this.
Do you
Point to
want a
that.
chair?
I might-
There you go.
Good morning, everyone. My name is Colby Barth. I'm going to be presenting ISIS Power Groups on behalf of my co-authors, Tony, Pavan, and Ron.
Can you be closer to the mic?
or maybe can we
Yeah.
can we raise it? You can raise it up a little bit closer to the.
Yeah, thank you. Yeah, thank you.
That's good.
Yeah, it's better.
There.
Better? Good?
Really?
Yeah.
Is the mic working?
Maybe it's my voice.
I think you just have to eat the mic.
Yeah, okay. At least I'm first. All right, good morning. Presenting ISIS Power Groups one more time. Okay, so Power Group aims to describe sort of an abstraction of the components within a router. The rationale for it is that our routing systems are pretty complicated, and without that abstraction, the ability to describe past, present, and future systems would be quite difficult. The interfaces can reference what power group they belong to, and therefore we can sort of organize these interfaces into this abstraction that corresponds to their relationship with power within a routing system. Why do we want to do this? Ultimately, the goal is to save power by turning off components in a system. And we aim to facilitate that by consolidating traffic through traffic engineering policies. One possible example is that we want to starve certain interfaces of traffic and therefore be able to transition them off. And this consolidation of traffic or consolidation of flows or tunnels facilitates that. And then we can construct TE policies as needed. It's probably obvious, but traffic engineering is a complicated animal. Operators have different requirements for different policies depending on their business. And this sort of abstract grouping aims to address that while also honoring certain other traffic engineering constraints. In order to do this, we're proposing 2 new top-level TLVs. The first being the power group TLV, which describes the group itself. We have an identifier. We have some power value that is representative of the abstraction. It may be such examples as max power of the forwarding engines, the connectivity between optics cages and forwarding engines, fabric cards, et cetera, et cetera. We have a parent identifier, which represents this hierarchy. And then last but not least, a bit for whether or not all of the interfaces advertised as members of the power group are power safe capable. The next top level TLV is a sleeping adjacency TLV. This is a list of adjacency TLVs that are currently in power sleep. In other words, we want to be able to remember that an adjacency has been put to sleep and not merely gone down. So differentiating between up, down, and power sleep. We're proposing 3 new sub-TLVs. The first of which is the power group member sub-TLV, which I mentioned on the first slide. This advertises which power group an interface belongs to. An interface may belong to multiple power groups. An obvious example would be a link aggregation group that spans multiple hierarchies within the system. The second is an interface power sub-TLV. So the actual operator defined power of the interface itself. It could be the max power of the optics cage. It could be, some instantaneous power, whatever the operator chooses to want to advertise. And then last but not least, a sleeping bandwidth sub-TLV. Again, here the idea is to advertise some portion of the total bandwidth that has been put to sleep. Similar to the sleeping adjacency TLV, we want to remember that bandwidth has been put to sleep. And the obvious use case, again, is a link aggregation bundle, where maybe some members of the AE bundle have been transitioned to power sleep. Next steps would be call for adoption. And thank you. Any questions?
All right. Nobody else is going to say anything.
Yeah, less.
Yes, okay. Yeah. Oh, yeah, there is a queue. Good.
Tell them to go ahead.
Less. Yes.
Yeah.
Go ahead, Les.
Okay. You guys can hear me?
Yes, we can.
Okay, good. Hi, Colby. Long time.
Yeah.
So just kind of a basic question. So you're asking the IGPs to advertise these sleeping adjacencies, but clearly when the power is off to the line card or what have you, we're not going to be able to maintain liveness. So how do you maintain the correctness of this while the power is off?
Well, so the assumption is that the system itself will make that decision to power itself off and or some sort of external application. And so the decision to go to power sleep is made in advance to actually going to power sleep. And the advertising system can first advertise the sleeping adjacency before turning the light off.
Yeah, but I'm saying, once you turn it off, you're clearly not able to send hellos, so you can't
Oh,
be assured that the connection is to the same guy that was there before you
y-
turned it off.
yeah. Okay, I
So-
understand your question. So how do we verify the link hasn't gone down after we put it to power sleep and we can't bring it
Or
back up?
connected to somebody else or what have you, who knows? Um,
Um, so I haven't thought much about if the connection changes. Um, however, we do have some ideas that are probably better discussed offline on how to maintain or periodically check for that liveliness to address the first thing I mentioned.
okay, thank you.
Yep.
I guess I'm next. AC Lindum, Arcus. I think, yeah, there regarding Les's comment on, there is some precedence on this. There was back when we were running OSPF over ISDN. There's the OSPF demand circuits, and we would bring down. We had all these, and that invented the do not age LSAs
Right.
and so there is some precedence, and you can't be sure. You cannot be sure. The other thing I'm wondering, is there? I know it doesn't necessarily belong here, but is anybody doing anything in the green working group where they have like a framework that not necessarily tells all the secret sauce of how you move things around, but has an overall problem statement?
As far as I know, yes, they've got lots of documents that describe reporting power by systems, use cases for saving energy, things of that nature. I'm not currently aware of anything similar to what we're describing here, but that doesn't mean there isn't something.
KU.
Hey, Colby. Keyur Patel, Arcus. Quick
Hi.
question. When you take a link out using this mechanism, is there a graceful way of taking that link out?
So again, that's probably a system specific question. I can say with my sort of Juniper vendor hat on that yes, we do various types of make before break procedures in our forwarding engines to ensure things happen gracefully, both for moving traffic from one link to another, as well as adding and removing members of a link bundle. Tony?
Several answers. Tony Lee, HPE. So to Les, the sleeping adjacency is not consistent, which is to say, once it's marked as a sleeping adjacency, you're correct. It may not come back up. It may come back up in a strange way. It may come up with a different adjacency. That's fine. The point of having the sleeping adjacency in the LSDB is so that TE can compute adjacencies that might come back up. And one of the things that we need to be able to do is to send a signaling request to turn things back on when traffic comes back up. To AC's question, the Green Working Group has an infinite number of documents, none of which seem useful. Thank you very much. I'm sorry, Kayur, you had a question. What was your question again? Oh, yes. When you're taking the link down, yes, you can do usual graceful things. Again, implementation dependent. An obvious thing to do is to max metric the link, right? And that'll push all the dark traffic away, and then you can go ahead and take it down. So.
Thanks, Tony.
So my understanding is the goal is trying to save power, right?
Correct.
So then how do you make sure the power group definition and the power consumption across different vendors and different equipment consistent? You need to have a consistent definition, right? And then you can calculate the best path.
Yes. Good question. So part of the motivation of the like abstraction, I think I mentioned it in the very first slide, is so that we can describe past, present, and future power systems. Because even here at Juniper HPE, if we compare all of our different routing systems, they're all different.
Exactly.
right?
That's the
I think maybe the second part or second answer might be, how do we compute a metric once we have these power group values, right?
Yeah,
So
'cause
that
you-
we
it-
can
like you
find
said,
the shortest path that we can consolidate traffic on.
all these
Yes.
routers, let's say, right? Even you assume they have the same architecture, so you can sort of group like the interface, the engine, do the right grouping,
Yeah.
but still they may not assume the same amount of power.
Correct.
Right.
So the second part of my answer would be, we assume that this is a policy that can be defined by the operator. So if, as an example, in most of our routing systems, you get the most bang for your buck by turning off the forwarding engines. So there's a natural hierarchy between the forwarding engine and any dependent interfaces. You can think of that as a dependency chain. So it's up to the operator to define a network-wide sort of dependency chain across the routing systems, and then therefore have a consistent deployment of power groups. Now, as far as computing the resulting metrics, my fellow co-authors and I have some different ideas and opinions about the best way to do that. But you could imagine one possible example is use the fewest number of most efficient power groups. Right? We know the bandwidth of every member interface. We know some value that gets advertised that's operator defined. It could be, say, the max power of the forwarding engine or the max power of the dependency chain. Calculate an efficiency metric and then use the least number of most efficient power groups. An alternative to that is what I would refer to as normalizing the metrics. So let's say you're doing a lowest delay sort of routing. Modify those delay metrics according to the max power that's advertised with each power group, and come up with a consistent mechanism for doing that across the network. Last part of my answer is, it's not defined in the draft, but we can of course talk offline about some CSPF enhancements that we've already prototyped for ensuring symmetry, traffic consolidation, and making sure these metrics are consistent.
Sounds to me you have a lot of ways. There might be multiple ways to normalize, right?
Yes.
Even
yes.
include even for power consumption, right? So
Yeah.
maybe you can add some details or some examples in the draft.
In the draft. Okay. Thank you.
That could be a draft in and of itself. I don't know.
Go ahead, Tony.
So my answer is a little different. If we have different vendors reporting different power architectures, TE is just going to do the wrong thing. Okay.
Exactly.
It's going to do something that's what it thinks is right. But if some vendor is lying, it's bad information. It's going to compute a wrong path. That's all we're going to see. You're going to get suboptimal stuff all the time.
So don't lie, I suppose, is the moral of the
Yeah.
story.
For different vendors, right? So you may have power group 1 and the other one have power group 2. They may consume the same power, right? So you don't know.
So the power group definition is an abstraction, very
Right.
much so. It is not supposed to be normalized across systems. Okay, we're not expecting system A is going to have the same architecture as system B. We're not assuming you've got the same component layouts or anything. All we're asking is that you report an accurate power usage per power group.
Oh.
And we're trying to do this in watts, and we think people understand what a watt is. That's pretty standard. Now that sounds funny, but it's not entirely obvious because there's peak utilization wattage, there's baseline wattage, there's current wattage, There's data sheet wattage. What we would really like to do is to have the best effort wattage, because that's the best we can ever do, right? So if people could report that, that would be the best thing.
Okay, thank you for that. Yeah, that's useful.
Do you want to do
No, I'm
one
not.
next, or do you want to see if we're how we feel about talking about adoptions with people? You know, how many people read?
We can do a raise the hands.
I think we need to some work here, and I liked your, this is SPF, so this would be the stingy path first, right?
All right. Thanks, everyone.
I'll just do it. How many people have read the draft?
We should do a thing if you want to figure about the.
Oh, yeah, okay.
Let's do it on,
Okay.
I don't, it doesn't mean I know how to do this. Jen, you know how?
She's the master of every,
Yeah, that's why I'm asking.
the meat echo
Yeah,
master.
Show of hands, I got it. Oh,
Yeah, I did the
you
poll.
got it.
Yeah.
So,
I'm not logged in.
Yeah.
I'm gonna vote
so
yes.
Everybody, show of hands that's showing up on the screen.
Yeah, especially for on-site participant, make sure you sign into the Meet Echo tool so you can do the
Yeah,
vote for
so
the
you can
poll.
vote.
I'm gonna vote no.
Uh,
Opinion, no
if you haven't, you can use your phone to scan the QR code. I think there is one at the mic and also by the door.
It should show us a percentage of. Thanks.
Yeah, me too. Maybe we should catch up.
I think last time I saw it was San Francisco.
Yeah. It's a long, long time ago. Yeah. It's like real time shaming here.
Sorry, could I make a comment about the
Yes,
the poll
please.
itself?
Yeah.
Is that there's no place to say not yet. You can either say yes or no. I guess my thought is it's premature.
Okay.
Yeah.
That's not to say
Well,
that at some point in the future I might not say yes.
That's
But right
a
now,
no then. Unfortunately, that's a
Okay.
no.
yeah, that's a no.
All
Yeah.
right, all right. I just thought I'd
So
clarify that. No,
if you think the document is not yet ready for adoption, please vote no. Yeah.
If folks are going to say not yet, we would very much appreciate understanding what you think is missing. What would it take to be ready?
And so we have 11 no's on the poll. So Tony's request is please let them know what can move you from no to yes.
Zafar, yeah, please.
Yeah, so I think there's a dependency. I think it's already mentioned that on the work that is going on the green, in terms of how you do, or what is the proper definition and understanding of these power groups, and how you find a normalization across the vendors. So I do believe that this is early to think about it. The encapsulation and anything is that dependency that needs to be sorted out.
Let's
Okay.
move to the next.
Yeah. So we'll do more discussion of this and what it takes to do it. I think, just speaking as a working group member, I think this is one of the first things where it doesn't have it in there, but I could look at it and I could visualize how TE would use this information, not necessarily at a high level. That's why I was asking if there was some problem statement that would provide some guidance in this area.
I mean, there are a lot more details that need to be taken into account when you do an interface or a resource or sleep a resource. So it's a lot of more component work that are required beyond the IGP extension. It's probably the last of the thing. But anyway.
Well, that doesn't need to be standardized though.
Oh,
I know it. Go ahead. You said it.
Yeah.
Okay.
Did that get recorded though?
Oh,
No.
it doesn't need to be, yeah.
Yeah, so I'll say it for you. AC said it doesn't need to be standardized.
Okay.
Yeah, so AC, just follow up on that. It's still the definition of the power group, and the work that is going on green is relevant to this.
So my thought actually, since I was speaking for somebody else, I'll speak for myself. My thought was, and I thought Tony might have been going to say this, is that based on the comment I heard earlier, which is that there are lots of documents. I mean, I think the authors may be trying to get something done, get something out there that works, right? And if you wait around, you can wait around forever for standards bodies sometimes, to do something if they're busy with lots and lots of documents, right?
So for the poll, I think we have about half of the people in the room and online altogether voted. So, and the result is about 50-50.
I think it says as soon as I hit the button.
Huh?
I thought when you hit terminate, it tells it.
Yeah. So I will close the poll.
Definitely speaking as chair, let's initiate a discussion on, more discussion on this draft.
Okay, let's go to the next presentation then.
Is this Leanne or Tony?
Yeah, I'm here.
Leanne.
Sorry, can I make Ketan Talaulikar? I'm just wondering if there is a thing called a liaison from LSR working group to the green working group, asking them to, work on something. Maybe the chairs could just send an email.
Okay. Subscribe over there.
Nothing that we've done, we think requires any cooperation from the Green Working Group.
Yeah, I agree with that.
Leanne, please go ahead and start your presentation, and you have control of the slides.
Okay, thank you. Hello, everyone. This is Li Yan from China Mobile, together with Chang Wang from New H3C Technologies. And I'm very pleased to present our draft. This draft proposes a metric normalization method for IGP flexible algorithms. And it's a new draft, and this is the first time to give the presentation. I will start with the problem we are trying to solve. In the network environment, there are often multiple paths between nodes with very similar but not identical metric values. We call it with some minor difference in metrics. As shown in this topology from R1 to R6, we have two paths, the green one through the R2 router and the right one through the R4 router. And you can see that because of the minor difference of the matrix between the link R2, 3 and the link R4, 3, R4, 5. So the final cumulative matrix of these two passes also have a minor difference. So in this situation, the ACMP cannot be formed, and this prevents the load balancing. And all the traffic will only use the optimal path, which has the smallest metric value, leaving the other one, the other path idle. So this ultimately results in the poor utilization of the network resources. Our goal is to enable these nearly equal paths to be used together, and we hope that will improve the link utilization. So this draft proposes a metric normalization adjustment method. The core idea is to make adjustments based on the existing link metric value. So for links with minor difference in metrics, after the adjustment, the metrics they advertise will be the same. So by adjusting the single link metric and the value of the entire link or entire path metric will be further affected. We hope so. And this method can be applied to various common matrix types, include the standard HP metric, the link delay T metric, and also the bandwidth. All the metric types complies to the RFC 9350 and 9843. And we think the key advantage of this proposal is its full compatibility with existing IGP routing algorithms. And it's very easy to extend and deploy without changing the core routing calculation logic. This is the specifics of the algorithm because it's rather abstract and not very easy to understand. So I will explain it quickly. And the next page, there will be specific examples to elaborate later. So here we introduce two configurable parameters. One is the metric step and the other is the metric offsite. In the metric step defines the granularity of the normalization, and the metric offsite is used to adjust the baseline value after the normalization. So this calculation process involves three steps. First step, we will calculate an intermediate value. We call it A. It's the link's actual metric divided by the metric type and rounded down using a floor function. And step 2, we calculate the value B, which equals multiplied by metric step plus the metric offsite. In the step 3, determine the final normalized metric. If the original metric is less than or equal to the value of the B, the normalized metric will be the B value. If the original metric is greater than the value of B, the normalized metric will become B plus the metric step. Here, I want to mention is that this formula we referred to the RFC 9843 for the mechanism of automatically calculating metric values, which is based on the link bandwidth. But we did not change the metric calculation method. We use it to adjust the metric value. So this adjustment will be made after the metric calculation is completed. So it's applicable to all types of metrics, which is with a border range, we think. And here is an example for better understanding. We will also use the previous topology. Suppose we are normalizing delay matrix, and we set the metric step to 10 and the metric offset to 3. For the link R23, the right one, the green one, and it has the original delay of 31. For the step 1, we should calculate a value A. It can be obtained by the 31 divided by 10 and also flawed. So the final result is 3. And the step 2, we should calculate the value B. Is the 3 times 10 and then plus 3. So the result is 33. And the step 3, since the original metric is 31, which is less than the B value 33, so its normalized metric becomes 33. And for the other link R45 with an original delay of 29, we also use this method to calculate the result. First step for the 29 divided by 10 and flawed. So the result is 2. And the step 2, the 2 times plus 2 times 10 and then plus 3 equals 23. Since also the original metric 29 is greater than the 23, so its normalized metric is 23 plus 10, which is 33. So it seems a little complex, but I think this is a very typical scenario for this method. And after the normalization, both links with original delays of 31 and 29 are advertised with same metric of 33. And this metric will be used for the path or route calculation. So we can get the ACMP path for R1 to R6. And they can also share the traffic load. This is our goal. We need some protocol extensions to deploy or implement this feature more simply, I think, and so comply with the current RFC 9350. We propose defining new subtheory types in the FAD subtheory for both SS and OSPF. So this new subtheory contains metric normalized information, and this information contains three fields. The first one is the metric type, and the second one is the metric step, and third one is the metric of site. And the metric type is the same with the previous slides we have mentioned, which is also complied with the RFC 9350 and 9843. And what I want to mention is that the protocol extension is just to simplify the configuration while also maintaining consistency across the multiple devices. I think that it's also acceptable to adopt a static configuration approach for each devices, but for Flex Algo, similar mechanisms already exist. So we also have made references in current RFC. So we hope this extension can make the deployment more easier. And that's all for our draft. And I would like to add one more thing here about the name of the draft. We are not quite sure if the term normalize is appropriate. So we also would like to listen the suggestion from the working group, and also any other questions and comments are welcome. Thank you.
AC Lindum Arcus. I'm speaking as working group member. I think it's a clever way to normalize the metric, so that's okay. The one thing I'd say is just a comment on the draft. In it, someplace you're using the term standardize instead of normalize. I think you got to just use normalize all over, even if it seems like it's repetitive, because it's not standardizing. I mean, it's not a standard. You're normalizing the metrics, and you're not really standardizing the SPF. It is already standardized. SPF is already standardized. The second thing, this is just for the TE. Now, TE is a big domain. When people see TE, they can mean a lot of different things. But normally, TE is computed by a single node, a controller or a single node head end or something like that. In those cases, you wouldn't need to advertise. It would be the person who's computing the TE path that would do something with that. And the third is, this is the most important comment. People have already implemented unequal multipath. Now that's where you just take paths and you make sure you add the path with a weighting factor, and you make sure that there's a pretty good possibility it won't cause a loop by doing this, and you have unequal. So would we really want to do this? when, although it's a, it's a local only, this is across, by advertising it, you do it across the domain and you have everybody do this. So you have less chance of looping. But would we really want to do this when people are getting along with unequal cost multipath and weighting? By weight, I mean WEIGHT, not WAIT. Sorry for talking. I probably talked too fast.
Thank you, Ise. I try to answer some of the question. The first one, yes, I think your understanding is very right. We just normalize the metric. We didn't standard or modify the computation or calculation of the SPF. So, so what I want to confirm is that do you think the normalized term is okay for this document?
Yes.
Oh, thank you. And we can update our draft to use this term because for the first version, we were not very sure about this. So maybe many words used in the draft is not very appropriate. Sorry for that. And sorry, I nearly forget about the second question. Can you repeat?
For the TE metrics, TE paths aren't computed across the domain normally. You don't need it for those, right?
Yeah, I also think so because the T metric is calculated maybe by the controller, not for the router itself. So for most scenario, I think it's not so useful as other metric tabs. But I don't know whether there are some scenarios for the head router to act the action similar with the controller, and they can also calculate the path. So maybe in this scenario is useful. But I think the key point of this draft is not for the single TE metric. We just want to make a same principle for all kinds of metric tabs. Maybe there will be other tabs other than these 4 tabs. We can use the same formula and the same extension for the protocol. I think it's easy to understand, and also it's good for future extension. Some compatible things. So this is my opinion.
Okay. I'm going to let Peter take his comment. We can take it to the list too.
Yes, thank you.
Peter Chenak, Cisco.
Hi.
Can you hear me?
Yeah, I can.
Doesn't seem to really work very well. Okay, so I have 2 comments. First is normalizing the metric is a good thing, but I don't believe anything needs to be advertised. It's a local behavior on a thing, on the router. You can think of it as a part of the measurement. I measure my delay or latency or whatever attributes. You measure it, you advertise, and as a part of this measurement, you can normalize it. There's absolutely no need why this would need to be done exactly the same on all the routers. You can configure the routers to do different normalization at different point in the network. It would just work fine. So you advertise the normalized value. There's no reason why you need to advertise how you normalize it. So that's my first comment. And the second comment is, if you take the example, the algorithms and everything from a particular vendor documentation, it's a good practice to put a reference at the end of the draft.
Okay, sorry. Sorry for the second question. Yeah, we forget this, so we'll update the draft to make the reference to the RFC. Sorry for that. And for the first question, I have just mentioned, but I also want to explain it further. I also think that for the static configuration, it can achieve this goal. For example, we can configure all the on all the routers for the two parameters, the metric granularity and also the metric offsite. But for advertisement, there have two advantage. I think first, it will simple the configuration. If you especially for the flex algorithm. Sorry, do you have any additional?
So, you know, the FAT is not a management advertisement. If you want to synchronize the configuration of the routers, there are management tools to do that. Flex algo definition is not the right mechanism.
Yes, but we want to comply with the current principle. For example, the current FAD also have this mechanism. And there are also existing methods to resolve the FAD confliction and some other things. So we think it's very mature method to advertisement. And the other advantage, I will go on. The other advantage, I think that is that it's a simple way to keep all the routers configuration consistent. You do not need to check whether or not the configuration are the same on the routers.
I see.
So
Yeah.
I agree. It's not a must option. So I think
guess.
it's a better. Thank you.
I don't know.
Yeah.
I don't see any smoke.
Well, that's not. You don't want to wait for that.
I don't know. I don't know what that is.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
Okay, Emerson, yeah. False alarm.
Okay, so let Leanne know that we're done.
Okay, Leanne, we'll take this discussion to the list. I think we had some good reasons why we wouldn't want to do this. But I'm speaking as a working group member. Okay, Tony, can you get your slides ready? We'll let the alarm go.
Yeah, you have my slides, no?
Yeah. Oh, yeah.
Can you hear the alarm on your end? Oh,
Absolutely. I already ran away. Even my dog's gone, man, after he heard that.
Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
well, what do you do? Do we run it or do we wait?
Wait till the beeping stops, yeah. Until he says,
Too disruptive. That's like a two-stage alarm.
Right, get ready.
And then run.
Right, get ready. Go.
So if the camera screens vanish into, snow, I know that you have been critically hit, that it was good I didn't travel.
No.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention.
Well, in Canada, things get serious when they start to speak French, right?
Please stand by for further instructions.
I think this is a recorded message. Yeah. Hour left. We have an hour left.
There was coffee out there. It's gone.
Oh, it is gone. Shit. Oh, when you went to the bathroom, there was one. Yeah.
Yeah, exactly. This is like literally there. 5 minutes ago.
Yeah. Attention.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
Tony, do you see the newer version of the slides? Can you check? Is this
Yeah,
a
look.
new version? Okay, yeah.
Even the clicker works. That is impressive. Good, excellent.
Yeah, I had to just upload it. Yeah.
Yeah, that's okay. I was still brushing this stuff up because I was caught like I told you in the meeting.
What have they said?
All right, should I start? We just ignore the French
They
speaking
reserve
gentleman,
the
or you want to wait?
signal, and they're checking it out. That's all.
Another signal has been received.
We don't know what the hell.
We are now investigating the cause. Please stand by for further instructions.
Really? So everybody, this is over the whole hotel. So
If the alert signal has been transmitted, somebody pulled the local fire alarm, or is it like some, like Amber Alert, right?
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
So now how do they turn it
False
on?
alarm.
Are they trying to figure that out? They don't know.
they haven't tested it.
Just a quick update here. Is this thing working?
Yeah.
So somebody pulled by accident like an alarm trigger thing. So there is no fire. So they're just waiting to fix it right now.
How do you do it by accident? The person should be shot, of course, purely by accident. Pour l'encourager l'autre.
Oh boy.
Another signal has been received.
I'm gonna go look for
We are now
There are
investigating the cause.
invested
Please
have
stand
some
by for
drama.
further instructions.
Yeah.
This is usually where this is the diversion,
This is the drama.
and somebody is assassinated during this time. Yes. Yeah. We find the body in the elevator.
It's still in my ear.
Wait, they're not doing anymore. Okay, Tony, I think we're gonna go ahead and get started. I'm hoping that people, you want to talk? Okay.
So, we lost all the audience. It's okay, fine.
They're coming back.
Good. So we start?
Yeah. Please go ahead.
No, okay. So I'm supposed to have a chat about where the stuff is going in some further aspects. I threw something together, and this is about the CSNP optimizations when we start to go really large scale, which actually, you know, we're seeing already with some customers. Maybe not as extreme that I'm talking, but you know, none of the stuff is getting smaller. All right, so. Lots of typos in the preso, just live with it. So CSNPs are presenting significant stress, right? 2K adjacencies, 4K adjacencies, something around, you know, a couple of 10,000 fragments, which is absolutely nothing special today for us. And we see that it takes a significant amount of I/O, of course, also computing in terms of synchronization of the databases. And since most of these networks are sitting completely stable most of the time, most of the stuff is periodic load that is totally useless overhead, both in CPU and I/O. But of course, we cannot do away with any of the CSNP stuff because this is our safety belt. If we ever, you know, blow out flooding or flooding start to hiccup for whatever reason, retransmission, whatever not. Okay.
Tony, I'm going to just break in once. Would this be used mainly when you're doing flooding reduction as well?
No, it's completely unrelated. It's totally orthogonal. It's totally orthogonal.
I guess that's why I work on OSPF.
Why? Because everything is a ball of twine. Yeah, I agree. No, it's completely orthogonal things, right? It's the total different optimization that we're looking at here. Either can work independent of the other. Now, good. So after giving it some thinking, or actually there were some ideas floating much earlier, but nobody bothered to write any detail. And I started to look at the stuff in more detail. And the stuff that pops to mind is a technique.
Hold on.
Hang on, Tony.
Yeah.
We got some.
Merci de votre collaboration. Vous pouvez maintenant retourner à vos postes de travail. Attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is now possible to return to your working area. Attention. Nos recherches indiquent qu'il n'y a pas de situation d'urgence. Merci de votre collaboration. Vous pouvez maintenant retourner à vos postes de travail. Attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is now possible to return to your working area. Attention.
Just in case you didn't hear the French version, yeah. Now imagine Switzerland is like 5 languages, man.
Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is now.
For those of you who have never ever experienced a DOS attack, you have now.
That sounded actually fine all there. Go ahead, Tony. If you could back up, just start the slide over.
All right, here we go. Before the next alarm comes up. Yeah, I know the presentation.
No.
Start from
no.
the next
You
one.
just the slide. You don't have to go to the beginning. Just start that slide over.
Right. Okay. So to keep it short, there is a well-established technique for this kind of stuff, like summarizing tons of information that floats around and try to synchronize it. And it's called Merkle trees. Old paper. This is widely used by people like Amazon and DynamoDB. It's in databases, well-known technique to synchronize partitions. All right. So how does it work? So it's basically a tree of hashes where hashes cover, a set of lower level hashes. If we just look at the picture, simplest stuff, at the very bottom, we have basically the CSNP entries, right? So A, B, C, D, E, F is just fragment description like we have them in CSNPs. And we run over this thing and we build a hash of that. And originally, the previous draft was suggesting some double hashing and so on. After Tony Lee, chimed in and I ran a good amount of code. It's much better to use a Fletcher checksum. Gives you much better entropy. Well, not much better, but noticeably better. And it's also less risky in terms of standardization if we go that way, because everybody knows how a Fletcher works, right? Whereas implementing a new reference algorithm bears its own risks. So now that we have these A, B, C, D, E, F Fletcher checksums, whatever size they are, we can take a bunch of those fragments and build a hash over it, which here is the rank 1, like alpha, beta, gamma, okay? Now, how we partition those things is, of course, a discussion that we'll have a little bit later, but let's assume we can do it in a clever way. And basically what we want to do is somehow to send out just the alpha and see whether it matches on the other side. And if it mismatches, then of course we have to send out A and B, basically the original CSNP, the rank 0. So it all regresses to CSNP. If the alpha, beta, gamma match, both guys exchanging them, then we know that we're in sync. All right. And this game can be played ad infinitum, right? So we can take in the rank further and actually build a hash over the alpha and the beta, and which will be the omega. No, what is it? Delta, sorry. And the capital beta over the gamma. Something like that, the green stuff, right? And if you take it to the very extreme, you end up with one single hash for the whole thing. So that's the core of the idea. And then, of course, the devil, as usual, is in all the gory detail. Good enough? Or should I field already? Because this is kind of core of the understanding. So I can field some questions if that is not clear.
Any questions at this moment? Tone.
Just to clarify, I know it's on the slide, but the A, B, C, D, are those entries in the CSNP? So those represent individual LSPs segments?
Fragments, yes, yeah.
Yeah, okay.
Yes.
Okay.
Yeah. So think of those as basically what we send is CSNPs, okay? Because that's really the best description of a fragment we have today, which identifies the fragments, in a unique way.
Okay.
Okay. Good. Now, so somebody says I'm actually pretty low. I have a mic very close. Let me know. Otherwise, I start, to talk louder. Okay, so now how do we partition those things, right? We could just build arbitrary sets and say like, oh, we just take a couple of fragments that change and we build the hash over that and we send that out. But if you start to think about how to send those things and compare them, because what we also have in the CSNPs, it's not only that we describe what is here, we also implicitly describe what is not here, right? Because we have a range on the CSNP packet that says from A to Z, but if we don't advertise C, the semantic is relevant. It means C is not there, and we need that. So we could build something where we start to send sets of things that are here and then things that are not here, but it's very hard to when to advertise things not being here if you don't know it's important they're not being here. So having tossed a couple of things around, we end up basically with CSNP-like things again, right? So we end up with a packet which has a range, and within this range, we stick the hashes with some ranges. So the whole thing is very close to the CSNP thing. I mean, I didn't put up the formats, but basically we have to totally order those things, and we build continuous partitions of continuous fragments, right? And looking, then the next thing that we start to realize that there will be again multiple of such HSNP packets around, right? We'll have multiple of those in flight, just like CSNPs. and they're kind of independent. Each describes a range, right? And if we go back and we go, well, yeah, exactly, John got it. So that's a typo, right? Stop cryptographic hashes, not caches. Yeah, sorry. So if we go like, well, cool. So let's basically take the set of those fragments. Let me go back to the previous picture because I think that parse is the best. So if we go like, oh, very cool. So like we built a strong cryptographic hash over A and B, right? And over C and D and F. Well-known techniques, very nice. The problem that we start to hit very quickly is that we don't know how to agree on the ranges on both sides. So if I send out A and B, but the implementation on the other side internally cached, not hash, cached ABC hash, then they're completely incomparable. So it's very hard to do anything with it. Every time you have to recompute a lot of cryptographic hashes, and then it becomes very, very expensive. So it starts to become natural from rank 1 and 2 and so on to start to talk about something where we can very easily build, reconstruct if difference in the hashes. And there is very few of such hash function of such properties, and the most natural is XOR, right? So if I have cached AB hash, but I get from my neighbor an ABC range hash, it's very easily for me to reconstruct it because I already have A and B. I just sort the C in, and I say, well, okay, now I can compare, right? Because running a protocol that will agree on what ranges we advertise to each other looked like a very, very deep rat hole. So that's the architecture. Yeah, Chris?
Oh, you can see me. So yeah, just something came to mind. You're trying to reduce this thing that we're doing periodically, right? I mean, the whole idea here is to reduce it. I think yeah. So why don't we just eat the cost the first time? Your neighbor gets the ranges with it, right? So the first time you have to calculate it, but then you know what the ranges are going to be, right? I mean, you're basically trying to lower the cost of not when things don't change, right?
Yeah.
So if things aren't changing, then you're just sending the one hash, right? And if they do, you're popping down, but only the first time does the neighbor have to calculate. It looks at the ranges that you sent, and then it has to calculate its hashes on its database to see if they're the same, right? But from that point forward, it knows what you're going to send it, right? You're going to send it the same ranges again. So you did the calculation one time, you don't have to do it a second time.
And that's valid thinking. Multiply that by 2,000 neighbors. And you realize it is not feasible because the amount of memory that you need to cache the stuff, because you cannot synchronize 2,000 neighbors that have to synchronize their own 2,000 neighbors on all the same ranges. You end up synchronizing the whole network on the same ranges, which is totally infeasible. Or otherwise, you have to compute for 2,000 neighbors, each of them with a different range, and advertise to them those ranges. Somehow you have to agree, right?
I see. Okay. Yeah. You're saying because if you standardize the range algorithm, the range splitting algorithm, it's the same for all neighbors. Okay.
And then the neighbors have to agree on their neighbors. So basically, you synchronize the whole network on the ranges. And the moment anything shifts in the network, everybody, have to run the whole thing. And it's a hell of a distributed algorithm. Okay, so that's, but I went we went down the same thinking pattern. And I started to implement it, to, as usual, simple idea, you start to implement and you go, oh, right? So there's a lot of O's here in this present. No good. So, I mean, none of the stuff is cast in stone. This is just, what we're running forward with and developing as a feasible solution. All right. So the other thing is that when we look at the partitioning, right, it looks like the simplest thing is to go basically minimum resolution is the system ID. And And I explained a little farther why, because, you know, how much you can cover and so on. And thanks to LAS, we include the pseudonodes. So we just eat the pseudonodes. They're mostly so small, it does not work to even, you know, go and advertise these pseudonodes bytes on the ranges. So think that the range is basically systems, right? So if we go to the previous picture, I try to go slow because I have time, right? And people wanted, you know, a slow explanation of the thing. So the A and B are basically already all the fragments of node A and node B. So think more like, think like that. The A, B, C, D, E, F are fragments, but the alpha, beta, gamma will always fall on a node boundary. So alpha will cover, you know, 1 node, 2 nodes, 3 nodes, whatever, beta, another couple of nodes, right? That makes for much denser packing. And if we look at numbers involved, it makes sense. And I show why. Okay. So as I said, at the very bottom, Fletcher, right? Because these are these single elements and they kind of frozen. So you can compute this Fletcher and cache it very easily. And then with XORing, imagine how easy it is to keep, for example, a hash per node. Because every time the fragment changes, you XOR out the old value and you XOR in the new value. So you can run very, very cheaply with the update algorithm, keeping basically hashes of all LSDB per node. Okay. Like I said, the XOR allows very easily to adjust for the ranges, or, you know, not calculate if you miss something in the range. If you have to add something to a range, it's very easily done. And then, of course, we don't want these ranges to like change all the time, right? So we allow for relatively loose packing, and I show what I mean by the packing. Okay. And then we slide these things, but the implementation is absolutely free to implement any way they want to do the stuff. So let me go more to the packing. Now, I'm trying from the packing. No, let's talk about the synchronization, right? So synchronization with the support the feature is very easy. You just on the hello, you say I support the feature or not. And the original thinking was that we have these ranks defined, like I'm advertising, I'm supporting up to rank 2, right? How many times you can summarize those hashes. At the very end, what I'm seeing, I'll show that what I'm seeing in implementation is actually superfluous. You know, this you can summarize any way you want, and the question is only how much will you generate when the hashes mismatch. And an implementation can be completely free of, you know, how much it wants to summarize together. And you can do it on very smart things like saying like, oh, these nodes never re-advertise, so I can basically start to summarize it more and more into a bigger and bigger hash. But I talk about the stuff at the very, very end. What happens when you mismatch, right? And what are the further implications? Okay. Now, there are some further considerations, and Les brought some arguments, and there is some discussions. So is it good to be very aggressive with the stuff where you start an adjacency? And it's, you know, it depends on assumptions. If you have an adjacency flap in a completely stable network, you basically ideally exchange one single hash and saves you the whole synchronization of the whole databases, right? If you assume that somebody booted a completely new node that has nothing, then you ideally want to start with CSNPs, naked CSNPs. But this doesn't need any standardization. I mean, the implementation can pursue any kind of strategy they choose. And I don't think there is a right answer, you know, when this thing is useful and when this thing is not, right? On a very, very large network, I mean, our experience is that mostly what you deal with is an adjacency flap. Or even if you bring up a new adjacency, the nodes are already synchronized. It's just one new adjacency. But that's, again, you know, like an assumption in a specific deployment. And then, as I said, we moved the draft to Fletcher for the fragments. But I didn't want to swamp you with the stuff that I put on the list, which is at the quality of node generated hashes and so on and so on. All right, so now comes, okay, so now probably comes the kind of controversial, most interesting stuff. And there will be a little bit of math, which I try to keep to the absolute minimum, right? Because now you say, all right, but these things are hashes. So what if two of those collide, especially since we XOR them? If you end up with two same hashes for two different fragments, and let's assume we just built one huge hash for the whole database, then they will cancel each other out, right? So this stuff doesn't cover it. So what are the probabilities? What are implications of the whole thing? How do we talk about it, right? So the first observation is that we don't have a perfect protocol today either, okay? So we may end up for some period of time with a database which is not synchronized on all the nodes, right? We have this whole that if a router reboots and it chooses the same fragment ID and it has different content, but the checksum is the same, we'll never discover that until a refresh, all right? We also have the problem of a Fletcher checksum being only 16 bits, so a 2-bit flip can actually, bypass the Fletcher. So we have a corrupt fragment hanging in the network, which we'll never discover. Now, since we're talking about, disasters, the answer is not like it will never happen. We're talking like, what are the likelihoods and how do we talk about this stuff? So basically, I thought that the simplest way to talk about this thing is some kind of a simple number, a disaster metric, okay? So what's the likelihood of something like that to happen, and how long will it last? And if we look at the same fragment ID with different content, same checksum, the probability of that happening is 1 to 65K, right? Because it's 65K checksum values. We assume, distribution is perfect. But it can persist up to a lifetime of a fragment, so up to 65,000 seconds, right? So the probability is 1 over 65,000 times 65,000 duration is the probability is 1. So you see my math with the 0.6 is BS there, it's a typo. So we have this normalized number 1 that we can have in a protocol. Yes, it's very unlikely, but if it happens, that's the impact on the database. Because that allows us kind of a metric to compare what happens when we start to do the hashing, okay? And then I talk also how we can alleviate it and so on and so on. So here comes the packing. So if we talk about this rank 1, level 1 is, we should cover about 70 fragments with a hash. Now, why 70? Because if that mismatches, it will generate exactly a single CSNP packet. I assume in the 1500 MTU, right? So when we fragment the LSDB, we probably want to stay around like 50, 60% of that. Implementation can choose, but you know how the fragment packing works. It's kind of the same problem. You don't want to be too excited about packing the TLDs densely because then you have to start to slide them, right? So now these things produce this range and a hash. And the hash is right now at 32 bits. If you look at how many of such hashes can you pack together in a packet, it's 80, right? So the next level of compression will cover about 5,000 fragments. So now you see already that we can cover with one packet, already with one level of compression, 5,000 fragments, which is a pretty sizable number. That's a good amount of customers. If we go one level up, the 80 repeats, right? Because now we cover the 80 of these first level hashes. And then with 500,000 entries. And you go, whoa, 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 it's why the hell would we have an IGP with 500,000 entries? It's actually not unreasonable. If you look at 65K lifetime and you have 500,000 fragments, that generates a continuous flooding load of only 10 packets per second, which is not bad. which means that we're pushing down the envelope, right, out of the IGP. We could run IGP at a couple of million fragments, well implemented, fine, right? Now, good. So let's talk now. What is all the likelihood of all this stuff colliding, right? And what is the impact in terms of how long the database would stay inconsistent? So we can basically assume that if something collides, so it's a birthday problem, right? How many people in a room do you need so they have the same birthday? It's precisely the same thing. Like I'm having 500,000 fragments. What's the chance that 232-bit hashes will be the same? So it's a birthday problem. Pretty familiar thing in combinatorics. So if we have now 65K lifetime, we can also assume that every 65K second divided by number of fragments, we get a refresh. It's a little bit optimistic, okay? You can argue that it's maybe not that evenly distributed, but it's something to start with. So now let's look at this level 1, where we do 70 fragments, right? What's the likelihood that the 70 fragments, there is a collision in hashes, 32-bit hashes? So the probability is 2.8 to e minus 7. So I was looking genius for it because numbers get really small. So you need to be wary when you do the math, you need arbitrary precision because these numbers become really small and really big. And we multiply it for the disaster metric. The duration of such inconsistency would be 65K second divided by 70 fragments because they refresh. So we get up with the disaster metric, it was about 1e minus 4. Now we go to level 2. And when you do the math, which is like 2e minus 2, and we go to level 3, and with level 3, which covers 500,000 of fragments, with a 32-bit checksum, funny enough, the probability is almost 1 that you have two same hashes. But they will only persist for 65,000 seconds divided by 500,000. Right? Because you have so much stuff, there's refreshes all the time. So you arrive at about 0.1 disaster metric. Okay, so it's still like 10 times better what we have cooked into the protocol already today, which you can say, oh, it doesn't ever happen, but it's not an argument here. Right, so this is the mathematical kind of indication how long can we have an inconsistency if we go to such a hashing scheme. Now, so let's make it better. We could, of course, go to a full 64-bit, sorry, not Fletchers, but hashes. Yeah, 64 Fletchers on the fragments. Easily done. But then, of course, the packets will blow up in size. So we cannot fit 80 ranges in it. We will fit maybe 40, right? So the whole packing will become much more inefficient. But if you look at the probabilities of collision, they become basically nothing, like e minus 10. So we can say almost impossible 500,000 fragments will ever generate the same 64-bit Fletcher. All right, one solution. If we, for example, go to something like 40 bits Fletcher, we're still pretty good with 6e minus 3, which is roughly in the range of what is the likelihood of 70 fragments colliding on 32 bits. It's a little bit worse, all right? So we can play with the Fletcher. We can also go to a solution where we say, well, okay, so let's go and send full CSNPs periodically. Okay, assuming the CSNP will never run into the original problem that I mentioned, right? And that will basically tell us, even if the hashes go out of sync or something bad happens, CSNP will catch it. But the problem is that 500,000 fragments generate about 6,000 CSNPs, okay? And if we flood with something like 10 packets per second, we need 10 minutes just to exchange CSNPs. So all of a sudden, you know, we're just doing nothing but sending CSNPs. So there is, you know, this does not sound particularly exciting. I was also looking at something like varying the seat of the Fletcher. So you flip the Fletcher initial value, so it generates different hashes every whatever time. But then we run into the problem how to synchronize 2,000 neighbors. If 2,000 neighbors flip the stuff all the time, and I'm calculating all the stuff, these Fletchers, my CPU will be glowing in the dark, and I can't synchronize everybody on the same seed because it's the same problem as the ranges. So that's that. Of course, I would appreciate a statistician telling me this whole thing is a very shaky thing, that I cooked up here. But it's kind of a metric where I thought would give us like a first approximation to talk meaningfully about we're all gonna die, okay, but how likely is it? All right, and the last thing that I've seen, around implementation, tinkering with the stuff, that the levels are totally unnecessary. So you can choose any packing strategy that you want, right? You can basically look at some nodes that refresh very often and say, no, I just put them into a tier 1 range, or some stuff that doesn't change at all. You go I pack it very densely into a very dense hash. And the only rules that are necessary is really if you hit a hash mismatch, right, from the other guy, then you have to deaggregate one level lower or whatever levels. And if you hit it on the lowest level when you had the 70 fragments or whatever hashed together, then you must send a CSNP for those guys. So it looks like it's up to the implementation to choose a strategy. Of course, we can give guidelines and so on, but there's nothing that forces the whole solution to be hierarchically ranked. And I think that's all that I have in this respect. And I can roll it back and go very slowly to the stuff because I know it's fairly dense, but that's the treatment of the subject.
We got some people on the queue.
Let's go through the queue. Go ahead, Les.
Okay, Tony, a few comments. First, I really do appreciate the mathematical work you've done, but I think a lot of it is irrelevant. And what I mean by that is we both agree that there's an existing possibility in the protocol that a node could generate an LSP that is undetectably different from another version of that LSP that was created, say in a previous incarnation. The HSNP stuff doesn't impact that at all, which is to say it doesn't detect that, it doesn't change the occurrence of that behavior. That's just something that's built into the the nature of how LSPs are generated and flooded. So I don't think it's that relevant to discuss those probabilities in the context of your proposed enhancement. What's much more important to me is whether this enhancement is actually going to be of practical value. It seems to me that the case that this has the most potential to add value is the case of periodic CSNPs. And clearly on a large LSP database, the number of CSNPs grows, and the number of BDUs you have to send periodically grows. But the protocol itself, the base protocol, does not use periodic CSNPs on point-to-point links. This was added and it's supported by a number of implementations later on. I think largely.
Practically everybody in the world does it on point-to-point links. So I don't know what theoretical concept we're bringing here.
I don't think that's true, Tony. There are implementations that do it by default, and there are implementations that don't do it by default. I'm not aware in the the many years that I've been involved in supporting deployments of the protocol that there has been a definitive problem in a customer network that was resolved by the use of periodic CSNPs. I would also point out, and I think AC would be delighted that I point this out, is that OSPF doesn't have periodic CSNPs, and nobody's claiming that OSPF is broken. So I think to demonstrate that this enhancement is actually of practical usage, you need to focus on the deployment cases where periodic CSNPs are really needed. And you have to look at what happens when databases are out of sync at the moment that the HSNP is sent, not because there's any problem with flooding, but just because there's an LSP that changed and both nodes have yet to, one guy has received it and the other guy has not. And in that case, you're going to get a mismatch on the hash, and you're going to degenerate potentially eventually to CSNPs, in which case, this isn't going to add value. So I think if you're going to, I have
a hard time to follow your chain of reasoning, Les. You say CSNPs are not needed, hence this is not needed. So if you don't need CSNPs, obviously you don't need this. But if you have CSNPs, then obviously this value. So where's this chain of reasoning?
No, I'm just saying that if you're going to use this, you've got to demonstrate that you're not going to get a significant percentage of shall I say, false positives, that you get a mismatch, but the mismatch doesn't actually represent a flooding problem. If you just waited another second or two, the two nodes would end up agreeing with each other. But at the moment the HSNP is received, one guy has a slightly different LSP database than the other just because he hasn't received the latest version of some particular LSP. So to me, the big question, and I hope what you'll focus on in future versions of the draft, is the scenarios in which this is actually of practical value, not theoretical value. Okay. Thanks.
Yeah, I have a hard time to follow this chain of reasoning. So there is a queue full. Maybe other people, have something productive to say. Okay.
Okay.
Did you want to reply or?
I'm happy to. Tony, Lee. So the practical situation for those of us who like CSNPs, because we like having a consistent database, is that HSNPs mean that your packet exchanges are logarithmic in the size of the LSDB, not linear. Okay, this is this key scalability point.
Right. So what? Oh, go ahead, Les.
No, I was just saying I completely understand that. The motivation for periodic CSNPs is based upon the possibility that flooding is compromised in some way. And I'm saying that in most deployments, this is not the case. If you look at, in fact, the dynamic flooding RFC, which we all worked on, there's discussion in there about, when periodic CSNPs might be used, and they're looked at, they're recommended basically during transient cases where you're changing the flooding topology. And I think it would be really good if you re-looked at what we've already defined in 9677 and see how that's relevant here.
So yes, there are cases where flooding has been compromised and CSNPs have saved our butts. This is operationally very useful. And the whole point is to have this backup mechanism that is actually cheap enough to actually use, because having a inconsistent LSDB is fatal.
So something that popped into my mind on this, well, you were talking about it, Les. I wasn't aware that about the discussion in the flooding draft on periodic, just as my own personal experience over the 20 years or whatever. I've always sort of counted on periodic CSNPs, and I'm not sure that we haven't, I mean, I don't know, and I can't say for sure, but I think we've even designed things along the way in this 20 years where we kind of were, we did some hand waving and said, well, you know, it's safe to do this because we, you know, everybody does periodic CSNPs anyway.
Yeah.
I can't actually pull anything right up out of my mind. So that, take that with for what it's worth. Maybe it's not worth much, but the other thing that yeah, so that sort of jumped out. I wasn't expecting to hear that we didn't really want to do periodic CSNPs.
Most of the flooding reduction various proposals we have all have sketchy cases.
Right.
Okay. They're not absolutely wrong, but they're operationally sketchy. And we've always said CSNP will save our butts.
Yeah. And yeah. So my other, so I guess you guys can continue to talk about that. I did see some circular stuff going on the list. I guess that didn't come up, but if it did, I wanted to clarify that so we could get out of that circle on the list. The Les never was claiming anything was 100%, you know, effective. So maybe we already moved past that. Okay, good. So the other thing that my own personal comment, totally outside of that disagreement, is I think I mean, I just saw the math now, Tony. The 1 in 65,000 case seems really low. I mean, the chance of collision is not just based on the 16 bits of the Fletcher, right? I mean, we're not like working with the randomized data that, you know, we're trying to avoid. It's you're talking about the case where the same node, right? Unless now we're changing sys IDs, right? But in effect, the same node has come up with the exact same LSP, the same sequence number, you know, and the same. I mean, the chances of the probability of that is not 1 in 65K, right?
Yeah,
It's way bigger than that.
No, that's why I was reading up very carefully. So that's why Fletcher actually, even with very little deviation in entropy, generates widely different values. And I measured that. Those are my emails with these funky graphs that were hard to understand. Fletcher is actually extremely good in this respect. Even if you flip a byte or change 2 bytes in, you know, where they are a couple of bits, it generates very well distributed.
Yeah, I understand. I'm just addressing when you were talking about CSNPs, right? So I'm just talking about a CSNP collision. Yeah.
Tony P's numbers are very conservative. Okay. You're absolutely right. They are way too conservative.
Yeah. Okay.
Okay. Because the structure and syntax of the LSP alone is enough to ensure that there's a whole lot of more redundancy. We've got more structure inside the packet that we depend on.
Yeah. So the reason that this occurred, the reason I wanted to point this out, right, was because then later on comparisons are made back against, you know, at least what I was seeing or hearing was HSNP is very similar to CSNP. And then that's when it becomes important to actually talk about when a collision happens, right? If we're going to compare the two things, we should be comparing apples and apples, right? And you can beat CSNP if CSNP looks like it has an amazing bad collision rate, right? Which is what I was seeing be said. It was saying 1 in 65K. Oh, well, we're close to that too. Well, no, you know, it's not 1 in 65K. It's way more, you know, whatever. That was my point. And with the HSNP, you are getting a little bit closer to like a randomized data set, right? Where now your collisions are, you know, they don't have all these extra restrictions on them, right? You got a bunch of hashes and stuff that you're hashing again. It doesn't feel the same to me. It feels like apples and oranges. So I'm a little uncomfortable with the comparison.
Look, Chris, the way you discuss it, bring up the math, lie at the probabilities, put up the assumption. We can talk about fears and feelings the whole day.
Yeah. I'm just saying that I don't like the comparison. It makes me uncomfortable.
All right. Well,
okay. Feeling acknowledged.
I'm not saying HSNP is bad. I prefer it stand on its own, and we just look at what the probabilities are on its own, not bring in CSNP collisions.
Fair enough. I wanted to normalize in some things and people have a reference, you know. How bad is it? Otherwise, it's just numbers, but it's fine with me. And as I said, if there is a solid statistician in the room, I would highly appreciate, some better treatment of the subject. But that's about what I could throw together on a quick notice. Okay. Hey, Hank.
Hey, Tony. So I just want to have a quick comment on your comparison between, the collisions. I agree. I mean, your math is solid. I have nothing to say. But I think we have to look at it from what is the impact. Because today, if you have a collision, it affects one fragment. In the case of an HSMP, if you have a collision of hashes, it may affect many fragments.
No, just two. No, just
Well,
two. What I put up was the birthday. If you talk about three guys collide, then it would be like minus 15. So what you want to do is to start to talk age of the universe probability. Is that a meaningful discussion?
It happens. We know that.
What happens if whole Amazon DynamoDB runs on Merkle trees? So okay.
What happens at a top level collision if you have one hash describing the whole database and you have a collision?
Well,
that's
so
not two.
That's what I said, and those are the probabilities. It's something like that and happen on 500,000, right? So
Right, but that's not two, right? That's the whole kit and caboodle.
No, the problem that you have is that two guys generate the same hash, right? And if you XOR them, they wipe out. You can say, of course, I have three, but then three will not wipe out each other. So you have to now start to talk. All the 32 bits have to correlate across 500,000. The probabilities of that is probably age of universe times 75 times. I can calculate them, but you see like e to the minus 200 or something.
Wow.
The most likely thing is that two hashes collide, right? And then you have the XOR problem. But if you don't believe that, please do the math, bring the probabilities. Because with feelings, you get nowhere. We have no intuitions for these kind of things. Those are things that are running, engineering minus 20. And we feel like it's really bad, but it's minus 200. So without math, we can go and fear, monsters in the dark, but you'll fear, I won't fear the discussion won't progress.
I'm just saying that you are calculating a checksum on the top of a checksum, right? And that if you get into the collision, you don't know where the collision is, which piece of data it affects. Possibly many. That's all.
But it only. Yeah, but like I said, without the math, I don't know what we talk about. We may talk e to the minus 200. And I acknowledge that you fear that, but I cannot quantify it. How can I have a meaningful discussion without quantifying the probabilities of that stuff?
Sure, we can work on the probability. I have no problem. But my point is that no matter what the probability is, it happens. And my point was that if it happens, what is the impact? And it can be larger than the impact of today's hashing collision. That's all I wanted to say.
Okay. But then don't forget, 500,000 of those things, you have, 10 of them per second refreshing. So then you
this is why you wanted CSMPs still, right? I thought that was the point of, yeah.
But like I said, if you start to talk about 500,000 of those, you're sending like 5,000 or 6,000 CSMP packets. So how often can you do that? All right, it's like, oh no, CSMP will be perfect. Well, they're not. If you have 1 million fragments, CSMP lose practical value because you can send them every half an hour. So your database will be inconsistent for half an hour, possibly. I mean, if we're talking 5,000 fragments database, this stuff is probably, unless you have a bazillions of adjacencies, of not that much interest. Once you start to stretch it to hundreds of thousands, then CSMPs become, very difficult to use. All right. But
okay, well, that was interesting. I think we're out of time, right?
Yeah, we'll just post the Yang. We'll let people look at the Yang update.
Yeah, so we're going to skip the Yang update. I have the slides uploaded in the meeting materials. If for people who are interested in it, can take a look. If there is any question, you can send an email to the list. And then I think that's it. Right?
Yeah, I meant to thank you, Tony, for presenting this again. And I think it's interesting work. And you've got a lot of interest, I think, right? It's a bunch of geeks talking about math and probabilities and.
Well, yeah, we thought we had a lot of time. Then we
Yeah,
had this
maybe
fire alarm trouble.
maybe it'll get more people like talking on the list other than just Les and you and Tony. Hopefully so.
Yeah, Tony actually prepared to represent some of the flooding graphs because we saw we had a lot of time turn out.
Yeah, I can just show one PowerPoint, the first PowerPoint, if you want. We have some further results, but nothing dramatic. So, I don't have to run the full pressure. Whatever you want, I'm fine either way.
Yeah, we could an egress slide.
No, actually, the first one. They just flip forward to the first one, and then we're done.
This one?
Yeah, exactly. So, what happened between the 9 and 11 now? We of course ran now tons of simulation testing, whatever, and we introduced better double hashing on the system IDs to balance better. We having discussion. Maybe we're going to regress to Fletcher. And then on 11, there were two things that came out. One was that there was a subtle detail with the shortest path removal, right? When you're flooding back. It wasn't clear that you have to remove all the ECMP paths back to the source, all right? So we clarified that. And the second one that we clarified that, if you have at a certain point in time, you say, I don't have the CPU, I don't have caching memory for the flood reduction results, then it's perfectly fine to regress to, full flooding at any given point in time for any given point in time. And the other interesting thing was that I ran a lot of tests and I switched off CSNPs, right? And the first thing I wanted to prove that and I was flapping a lot of links on topologies. And I wanted first to see that the stuff never ends up with inconsistent databases because of the reduction. And, I've proven to myself the correctness as far as I could do it in simulations, which is not a formal proof. And then the other measure I tried to look at was, we have this PSNP hack, right? Like you don't flood, just give the guy a PSNP so he knows you didn't flood. And if, the reduction would not do its job, it causes the other guy to request the stuff. Or whatever, on retransmissions. And first I wanted to see how much of this PSNP stuff was actually triggering the fixing of the topology, but it's impossible to differentiate. I mean, you can think about the problem, but basically standard PSNP and these PSNPs and whether you flood or not at the end, it's indistinguishable. So I ended up just looking at the volume. Does this stuff start to generate much more PSNPs, right, when it runs reduction or something like that? And I didn't see any difference. So the volume was pretty much what it was when I clicked on CSNPs and, when I was not running reduction. So it basically shows that the stuff holds up with our CSNPs when you flap a lot of topology. But that's about it. So, that's all I have to add. And the rest is all the previous stuff. I'm done. Thanks.
Okay, so we'll continue the discussion on the mailing list. Thank you, everybody, for your attention. See you next time.
Are you following Vesta?
Just showing you that.
No.